out this YouTube video. It just went up, super big, so many views. Have you guys seen it at all?
No.
No, I haven't seen it yet. What's it all about? Is it better than the Harlem Shake?
Way better than the Harlem Shake.
Let's see.
Not serious.
So serious.
Analysis of variance, or ANOVA, is a statistical technique which measures the degree of variation between a dependent variable amongst three or more distinct populations, which may be produced by the independent variable. For example, the textbook examines the impact of teaching methods, the independent variable, such as lab-based, lecture-based, or online-based, on the exam scores, the dependent variable, of different populations of students. If the difference in impact is large enough to reject the researcher's null hypothesis, the researcher can conclude that the study's populations are distinct and can confidently assume that the research hypothesis is correct. ANOVA calculations follow the same 5-step procedure outlined in earlier methods of hypothesis testing. Moreover, ANOVA calculations also require a 6-step test, which is used to determine whether the sampled populations are significantly different. This intent of the calculation is parallel to earlier methods of hypothesis testing, as it is based on determining whether the F obtained falls outside or within F critical, and can be depicted in terms of locations on a normal curve. The calculation for determining the degree of difference between populations is based on the degree of difference between the categories, or sum of squares between, relative to the variation within the categories, or sum of squares within. The null hypothesis holds that the sum of squares within and the sum of squares between are roughly the same, while the research hypothesis stipulates that the sum of squares between is high relative to the sum of squares within. While ANOVA can be used to generate enlightening analyses via confidently determining whether differences exist between variables, its calculations are limited by the fact that they require precisely measured dependent variables, as well as roughly equal sample sizes or roughly equal sample variances. However, ANOVA possesses some durability under these limitations and can still be effectively used if these requirements are not directly met. Moreover, ANOVA tests, which confidently determine that there is a difference between populations, are not able to determine where the difference comes from. For example, are all these categories equally different? Or does a large difference from one category skew the total degree of difference between all the populations? We will now proceed to our SPSS overview to determine how these techniques fare in practice, using variables and data from the 2006 census. Exercise 9.1 refers to conducting a one-way ANOVA test. In order to conduct the first ANOVA exercise, we must transform our independent variable, provinces, into the new variable titled regions. This is done in order to equilibrate the size of the provinces' populations by lumping together provinces and comparing them on the basis of groups rather than separately. We transform variables by using SPSS's recode command to collapse the variable provinces into 3 regions. First, click the transform command on the main menu, and then choose the recode into different variables command. Hit the arrow to transfer the variable provinces into the output variable box. In the output variable box, click Name as the text suggests. This variable should be titled as Regions. After doing this, click the Change button. Secondly, click on the Old and New Variables button. This will open the Recode into different old and new values dialog box. You can change the values of the variable by inputting the old value into the old text box and creating a new variable. This can also be done with a range of old values, which can be compressed into one new value using this technique. Our first variable, which was represented 10 through 24, will now be represented as 1 in our new variable. This new variable now includes Atlantic Canada and Quebec. Our second variable, which was represented as 35, will now be represented as 2, which symbolizes Ontario. Our final variable, which was represented as 46 through 59, will now be represented as a 3, which now includes Manitoba, Saskatchewan, Alberta, and British Columbia. Now click Continue, and then OK. We can now perform a one-way ANOVA test with our new variable regions. To perform this test, click Analyze. Then compare means, and enter the variable gross rent into the dependent variable list box. Next, place the variable region into the factor box, click the Options section, and check if descriptive in the Statistics section. Then click Continue, and then OK. This chart indicates that there is a distinct difference in the mean level of gross rent in Western, Central, and Eastern Canada. Since the F ratio is 15.363 and above our F critical of 2.99, and our significance is lower than 0.05 or 5%, we can confidently say that there is a statistically significant difference between these populations' means and thereby reject our null hypothesis. Exercise 9.2 refers to creating an error bar graph. As previously highlighted, ANOVA tests can tell if there is a difference between any of the group of variables' means, but it cannot tell us which groups differ significantly from each other. We can use an error bar graph to better help understand the character of the differences between the means. To produce an error bar graph at the 95% confidence interval, click Graphs, Legacy Dialogs, and then the error bar. Click Define button and then transfer the dependent variable gross rent into the variable box. And then transfer the category region into the category access box and then click OK. We can eyeball the overlapping of confidence intervals for each mean to draw a sense of which means are significantly different. From the error box graph, we can better conceptualize the differences between the means of these three populations. While there is no statistically significant difference between Ontario's gross rent as well as Western Canada's, represented as 2 and 3, there is a large difference between Atlantic Canada and Quebec's gross rent, represented as 1, compared to Ontario and the Western provinces. From this graph, we can tell that the statistical significance in differences between these populations' means, highlighted by the ANOVA test, is due to the disproportionate differences in gross rent levels between Western and Central Canada compared to the Eastern provinces.
So what'd you guys think? Did it blow your minds?
Yeah, totally. Yeah,
Crazy, right?
Yeah.